Hi everyone, this is question number 5 in chapter 2, differentiation. So in this question, we need to find the differentiation of y with respect to x by using the first principle. So over here, I just show you the steps to find dy dx by using this first principle method. The detailed explanation will be in another video. So please click the link in the description box to find out why is this method. Okay, so let's use this first principle directly. So if we have y equals to 3x plus 5, so y plus del y. So this is the method of first principle. Yeah, why is it so? Please watch the link, the video as suggested. Okay, get the link in the description box. So x plus delta x. Okay, I will keep saying del x for delta x. Okay, so we have 3x plus 3 del x plus 5. And 3x plus 5 is actually y. So replace it with y plus 3 del x. So y plus del y equals to y plus 3 del x. So obviously del y will equals to 3 del x. So our objective is to find dy dx, and it is equal to the del y del x only when we set the limit of del x approaches 0. Okay, therefore, since this is 3, so the limit of del x approaches 0 of 3, there's no del x for us to substitute, so the answer is just 3. Okay, so that is part A. Now let's go to part B. We have y equals to x squared minus 7, so same thing. Okay, we find another coordinate that is very near to original point, xy. So y plus del y, and then x plus del x squared, and then minus 7. So next is to expand. So x squared plus 2x del x plus del x squared, and minus 7. And we know that x squared minus 7 is actually y. So y plus 2x del x plus del x squared. So obviously we know that del y is 2x del x plus del x squared. Okay, and therefore del y by del x will be 2x plus del x. And don't forget the objective is to find dy dx. That is when we set the del y by del x such that del x approaches 0. Okay, and we substitute del x equals to 0. So dy dx is 2x. Okay, so that is B. Now let's go to C. So for C, y equals to x squared plus 2x plus 1. So the first principle, we are looking for another point that is very much close to the y itself. So same thing, x will also experience the very small changes. Okay, and then plus 2x plus del x, and then plus 1, extend. So x squared plus 2x del x plus del x squared, and then plus 2x plus 2 del x, and then plus 1. And then from here, x squared plus 2x, and then plus 1 is actually our y. So y equals y plus 2x del x plus del x squared plus 2 del x, okay? And therefore, obviously, del y is equivalent to 2x del x plus del x squared plus 2 del x. And definitely, we need to get del y by del x, dividing both sides with del x, so we're left with 2x plus del x plus 2. Okay, so dy dx, okay, will be the limit of our del y by del x as del x approaches 0. So when del x is almost 0, we have our dy dx equivalent to 2x plus 2. Okay, substitute this to be 0. So we have 2x plus 2. So dy dx for question C is 2x plus 2. Now let's go to part D and part E. It will be more complicated. Okay, so dy equals to negative x cubed plus 9. So we take y plus delta y equivalent to x also experience the small changes, cube plus 9. Okay, expand the cubic expression. There is a formula to expand the cubic expression. You can click the link at the description box and see what is the formula to do this. Okay, so let's just do this directly using the formula. So x cubed plus 3x squared delta x plus 3x delta x squared, and then delta x cubed. Okay, so this whole thing plus 9. So open up the square bracket. So we have negative x cubed plus, minus 3x squared delta x minus 3x delta x squared minus delta x cubed plus 9. And from here, we know that negative x cubed plus 9 is actually the y. So the y and the y on the left and on the right, we minus each other. So we left del y equivalent to negative 3x squared del x minus 3x del x squared and minus cube of del x. And then always divided by del x on both sides. So we have negative 3x squared minus 3x del x minus del x squared. Okay, and then to find dy dx, we just need to find the limit of our del y by del x as del x approaches 0. So let's just put that in. And then we substitute del x with 0. So we're left with negative 3x squared. Okay, so this is the dy dx for the cubic expression. All right, now let us move on with part E. Right, part E is the reciprocal function. Okay, so let's just do part E here. Now E, y equals to 2 minus 3 over x. So y plus del y equals to 2 minus 3 over del x. X plus del x. X plus del x. Okay, so what do we do here? We take away, bring the y to the other side because our objective is to make del y the subject first. So we have 2 minus 3 over x plus del x minus the y. So the y is 2 minus 3 over x. So open up the bracket, we have 2 minus 3 over x plus del x minus 2 plus 3 over x. So the 2 and the 2 minus will get 0. So we will have 3 over x minus 3 over x plus del x. And then find the lowest common multiple to combine these two fractions. So we have 3x plus del x minus 3x. So now our denominator is x times x plus del x. Open up the bracket. So we have 3x plus 3 del x minus 3x. Now the bottom part, we open up the bracket as well. X squared plus x del x. If we don't open, it's fine. Doesn't really matter. Okay, so next, after we got the del y, so now we need to divide both sides with del x. So del y by del x we will have divide. Oh, yeah. So divide del x of this. At the same time, 3x minus 3x. So we're left with just 3 del x over x squared plus x del x. And the delta x can be simplified. So we're left with 3 over x squared plus x del x. And don't forget, our final objective is to find dy dx. That is when we set the limit of del y del x as the del x approaches 0. So 3 over x squared plus x del x. Okay, so now as del x approaches 0, so equivalent to 0, we left with 3 over x squared. So that is the answer. Okay, so that's it for question number 5.